This video is created by Nihar from YouTube. This video is created by Nihar from YouTube. What is resistor? A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines, among other uses. High-power resistors that can dissipate many watts of electrical power as heat may be used as part of motor controls, in power distribution systems, or as test loads for generators. Fixed resistors have resistances that only change slightly with temperature, time, or operating voltage. Variable resistors can be used to adjust circuit elements, such as a volume controller or lamp dimmer, or as sensing devices for heat, light, humidity, force, or chemical activity. Aluminum-housed power resistors are a preferred choice. Take for instance, the pre-charged circuit of an electric vehicle or the surge protection system of medical equipment. The key requirement in these applications is quick heat dissipation during high-power operations. At the same time, the resistive element needs to be compact in size and maintain relatively low surface temperature. As the name suggests, these high-power resistors are wire-wound resistors encapsulated in an anodized aluminum housing, which itself acts like a heat sink. The aluminum casing may be further bolted onto an external heat sink to maximize heat conduction. A wide range of resistance values can be supported using this type of resistor. The goal is to ensure maximum winding uniformity, rapid heat transfer, reliability, and stability for the connected device. This type of construction is used for the highest power levels. 2 power resistors. Power resistors are designed to withstand and dissipate large amounts of power. In general, they have a power rating of at least 20 watt. They are made from materials with a high thermal conductivity, allowing efficient cooling. They are often designed to be coupled with heat sinks to be able to dissipate the high amount of power. Some might even need forced air or liquid cooling while under maximum load. Some are wire-wound, some are made from wire grids for ease of cooling, but the common thing for all power resistors is that they are built to dissipate the most power while keeping their size as small as possible. An example used for power resistors are load banks used to dissipate power generated during engine braking in vehicles using electrical motors, such as locomotives or trams. 3 wire-wound. High-power wire-wound resistors used for dynamic braking on an electric railway car. Such resistors may dissipate many kilowatts for an extended length of time. Types of windings in wire resistors. Common on a thin formerton periwound resistors are commonly made by winding a metal wire, usually nichrome, around a ceramic, plastic, or fiberglass core. The ends of the wire are soldered or welded to 2 caps or rings attached to the ends of the core. The assembly is protected with a layer of paint, molded plastic, or an enamel coating baked at high temperature. These resistors are designed to withstand unusually high temperatures of up to 450 degrees C. 12 wire leads in low-power wire-wound resistors are usually between 0.6 and 0.8 mm in diameter and tinned for ease of soldering. For higher power wire-wound resistors, either a ceramic outer case or an aluminum outer case on top of an insulating layer is used. If the outer case is ceramic, such resistors are sometimes described as cement resistors, though they do not actually contain any traditional cement. The aluminum case types are designed to be attached to a heat sink to dissipate the heat. The rated power is dependent on being used with a suitable heat sink, e.g., a 50 watts power rated resistor overheats at a fraction of the power dissipation if not used with a heat sink. Large wire-wound resistors may be rated for 1000 watts or more. 4 carbon composition resistor. The resistive element is made from a mixture of finely powdered carbon and an insulating material, usually ceramic. A resin holds the mixture together. The resistance is determined by the ratio of the fill material, the powdered ceramic, to the carbon. Higher concentrations of carbon, which is a good conductor, result in lower resistance. Carbon composition resistors were commonly used in the 1960s and earlier, but are not popular for general use now as other types have better specifications, such as tolerance, voltage dependence, and stress. Carbon composition resistors change value when stressed with over voltages. Moreover, If internal moisture content, from exposure for some length of time to a humid environment, is significant, soldering heat creates a non-reversible change in resistance value. Carbon composition resistors have poor stability with time and were consequently factory sorted to, at best, only 5% tolerance. 10 These resistors are non-inductive, which provides benefits when used in voltage pulse reduction and surge protection applications. 11 Carbon composition resistors have higher capability to withstand overload relative to the component size. 12 Carbon composition resistors are still available, but relatively expensive. Values ranged from fractions of an ohm to 22 megohms. Due to their high price, these resistors are no longer used in most applications. However, they are used in power supplies and welding controls. 12 They are also in demand for repair of vintage electronic equipment, where authenticity is a factor. 5 Carbon pile resistor. A carbon pile resistor is made of a stack of carbon discs compressed between two metal contact plates. Adjusting the clamping pressure changes the resistance between the plates. These resistors are used when an adjustable load is required, for example in testing automotive batteries or radio transmitters. A carbon pile resistor can also be used as a speed control for small motors and household appliances, sewing machines, handheld mixers, with ratings up to a few hundred watts. 13 A carbon pile resistor can be incorporated in automatic voltage regulators for generators, where the carbon pile controls the field current to maintain relatively constant voltage. 14 The principle is also applied in the carbon. 6 Carbon film resistor with exposed carbon spiral. Tesla TR212 1K8 carbon film is deposited on an insulating substrate, and a helix is cut in it to create a long, narrow resistive path. Varying shapes, coupled with the resistivity of amorphous carbon, ranging from 500 to 800 them, can provide a wide range of resistance values. Compared to carbon composition, they feature low noise because of the precise distribution of the pure graphite without binding. 15 Carbon film resistors feature a power rating range of 0.125 watts to 5 watts at 70 degrees centigrade. Resistances available range from 1 ohm to 10 megohm. The carbon film resistor has an operating temperature range of 55 degrees centigrade to 155 degrees centigrade. It has 200 to 600 volts maximum working voltage range. Special carbon film resistors are used in applications requiring high pulse stability. 7 A single in-line, SIL, resistor package with 8 individual 47 ohm resistors. This package is also known as a SIP9. One end of each resistor is connected to A to control the current in a circuit. Series connection is useful. Sensory chip or processor appliance in short circuit can be prevented by connecting the fuse in series with the mains, as well as the electronic appliance. 8 Carbon composition old-style dogbone resistors with body, tip, color code marking. 3 Carbon composition resistors in a 1960s valve, vacuum tube, radiocarbon composition resistors, CCR, consist of a solid cylindrical resistive element with embedded wire leads, or metal end caps to which the lead wires are attached. The body of the resistor is protected with paint or plastic. Early 20th century carbon composition resistors had uninsulated bodies. The lead wires were wrapped around the ends of the resistance element rod and soldered. The completed resistor was painted for color coding of its value. 9 Carbon pili. A carbon pile resistor is made of a stack of carbon discs compressed between two metal contact plates. Adjusting the clamping pressure changes the resistance between the plates. These resistors are used when an adjustable load is required, for example in testing automotive batteries or radio transmitters. A carbon pile resistor can also be used as a speed control for small motors and household appliances, sewing machines, handheld mixers, with ratings up to a few hundred watts. 13 A carbon pile resistor can be incorporated in automatic voltage regulators for generators, where the carbon pile controls the field current to maintain relatively constant voltage. 14 The principle is also applied in the carbon microphone. 10 Carbon film resistors. Carbon film resistor with exposed carbon spiral. Tesla TR212 1K8 carbon film is deposited on an insulating substrate, and a helix is cut in it to create a long, narrow resistive path. Varying shapes, coupled with the resistivity of amorphous carbon, ranging from 500 to 800 them, can provide a wide range of resistance values. Compared to carbon composition, they feature low noise because of the precise distribution of the pure graphite without binding. 15 carbon film resistors feature a power rating range of 0.125 watts to 5 watts at 70 degrees centigrade. Resistances available range from 1 ohm to 10 megohm. The carbon film resistor has an operating temperature range of 55 degrees centigrade to 155 degrees centigrade. It has 200 to 600 volts maximum working voltage range. Special carbon film resistors are used in applications requiring high pulse stability. 11 printed carbon resistors. Carbon resistors, black rectangles, printed directly onto the SMD pads on a PCB. Inside a 1989 vintage Xeon 2 organizer, carbon composition resistors can be printed directly onto printed circuit board (PCB) substrates as part of the PCB manufacturing process. Although this technique is more common on hybrid PCB modules, it can also be used on standard fiberglass PCBs. Tolerances are typically quite large and can be in the order of 30%. A typical application would be non-critical pull-up resistors. 12 thick and thin film laser trim precision thin film resistor network from Fluke, used in a Keithley DMM7510 multimeter. Ceramic backed with glass hermetic seal cover. Thick film resistors became popular during the 1970s, and most SMD, surface mount device, resistors today are of this type. The resistive element of thick films is 1,000 times thicker than thin film 16, but the principal difference is how the film is applied to the cylinder, axial resistors, or the surface, SMD resistors. 13 metal film. A common type of axial leaded resistor today is the metal film resistor. Metal electrode leadless phase, MELF, resistors often use the same technology. Metal film resistors are usually coated with nickel chromium, NiCr, but might be coated with any of the ceramic materials listed above for thin film resistors. Unlike thin film resistors, the material may be applied using different techniques than sputtering, though this is one of the techniques. Also, unlike thin film resistors, the resistance value is determined by cutting a helix through the coating rather than by etching. This is similar to the way carbon resistors are made. The result is a reasonable tolerance, 0.5%, 1%, or 2%, and a temperature coefficient that is generally between 50 and 100 ppm. K18 metal film resistors possess good noise characteristics and low nonlinearity due to a low voltage coefficient. Also beneficial are their tight tolerance, low temperature coefficient, and long-term stability. 14 metal oxide film. Metal oxide film resistors are made of metal oxides, which results in a higher operating temperature and greater stability and reliability than metal film. They are used in applications with high endurance demands. 15 foil resistor. Metal foil resistor. In 1960, Felix Zandman and Sidney J. Stein 19 presented a development of resistor film, a very high stability. The primary resistance element of a foil resistor is a chromium nickel alloy foil, several micrometers thick. Chromium nickel alloys are characterized by having a large electrical resistance, about 58 times that of copper, a small temperature coefficient, and high resistance to oxidation. Examples are chromal A and nichrome V, whose typical composition is 89-20 Cr, with a melting point of 1420 degrees centigrade. When iron is added, the chromium nickel alloy becomes more ductile. The nichrome and chromal C are examples of an alloy containing iron. The composition typical of nichrome is 60 12 Cr, 26 Fe, 2 Mn, and chromal C, 64 Ni, 11 Cr, Fe 25. The melting temperature of these alloys are 1350 degrees and 1390 degrees centigrade, respectively. 16 ammeter shunts. Resistorcyne ammeter shunt is a special type of current sensing resistor, having 4 terminals and a value in milliohms or even microohms. Current measuring instruments, by themselves, can usually accept only limited currents. To measure high currents, the current passes through the shunt across which the voltage drop is measured and interpreted as current. A typical shunt consists of 2 solid metal blocks, sometimes brass, mounted on an insulating base. Between the blocks, and soldered or brazed to them, are 1 or more strips of low temperature coefficient of resistance, TCR, manganese alloy. Large bolts threaded into the blocks make the current connections, while much smaller screws provide voltmeter connections. Shunts are rated by full-scale current and often have a voltage drop of 50 mV at rated current. Such meters are adapted to the shunt full current rating by using an appropriately marked dial face. No change need to be made to the other parts of the meter. 17. Grid resistor in heavy-duty industrial high-current applications. A grid resistor is a large convection-cooled lattice of stamped metal alloy strips connected in rows between two electrodes. Such industrial-grade resistors can be as large as a refrigerator. Some designs can handle over 500 amperes of current, with a range of resistances extending lower than 0.04 ohms. They are used in applications such as dynamic braking and load banking for locomotives and trams, neutral grounding for industrial AC distribution, control loads for cranes and heavy equipment, load testing of generators and harmonic filtering for electric substations. 22. The term grid resistor is sometimes used to describe a resistor of any type connected to the control grid of a vacuum tube. This is not a resistor technology, it is an electronic circuit topology. 18. Adjustable resistors or potentiometers. Typical panel mount potentiometer. Drawing of potentiometer with case cutaway, showing parts. A. Shaft. B. Stationary carbon composition resistance element. C. Phosphor bronze wiper. D. Shaft attached to wiper. E. G. Terminals connected to ends of resistance element. F. Terminal connected to wiper. A. An assortment of small through-hole potentiometers designed for mounting on printed circuit boards. A potentiometer, colloquially pot, is a three-terminal resistor with a continuously adjustable tapping point, controlled by rotation of a shaft or knob, or by a linear slider. 23. The name potentiometer comes from its function as an adjustable voltage divider to provide a variable potential at the terminal, connected to the tapping point. Volume control in an audio device is a common application of a potentiometer. A typical low-power potentiometer, see drawing, is constructed of a flat resistance element, B, of carbon composition, metal film, or conductive plastic, with a springy phosphor bronze wiper contact, C, which moves along the surface. An alternate construction is resistance wire wound on a form, with the wiper sliding axially along the coil. 23. These have lower resolution, since as the wiper moves the resistance changes in steps equal to the resistance of a single turn.